About method overriding. So in our lessons package, I will right click and create a new class. I go to new and I'm gonna create a new class, and I am going to call this class override. Just call it override. Override with capital O. Let's call it override. So we have our new class here. Now when a method in a subclass has the same name as a type signature, or rather when a method in a subclass has the same name and also a type signature as another method that is in superclass, the method in the subclass is going to override the method in the superclass. In other words, methods that are in the subclasses that have the same name and also the same type signature will ride methods in the superclasses that have the similar names and similar type signatures. So when the overridden method is called in its subclass, then it is going to refer to the version of that method that is in the subclass. So the version in the superclass is hidden. That is what we call overriding. The method in the superclass is hidden. Now to understand this, we need to work with an example. Of course, programming concepts are well understood with programs. So we are talking about method overriding, and we are going to create a class that is going to be a superclass, a class A. I have used A so much, a class A, and I'm going to give it int I comma j. I'm going to give it two variables, and I'm going to create a constructor, and this constructor is going to take two parameters, int A comma int B, and then I'm going to set it up here by saying that I is equal to A and J is equal to B, and J is equal to B. So again, I am going to have a method in this particular superclass that is going to display I and J. This method is going to display I and J. So I'm going to call the method show. So it's say void show. I'm just going to call it show, and it takes no parameters. And then we're going to have a print statement. So system.out.println, system.out.println. What we're gonna have right now is I and J. So we want to print to show I and J. So we're just going to say plus space plus I plus another space, we say plus J. Okay, then we move on to now having a subclass by extending the superclass A. So let's have a subclass B. So we can say class B extends A. Class B extends A, and it's gonna have an addition element that is K. So int K, just a moment, I see an error here. I need to address it, need to know what it is right now. Implicit super constructor A is undefined for default constructor. Class B extends A, class A. Okay. Class B extends A. Let's come here. I don't know. I really don't know what is happening here. What's the issue? Implicit superconstructor A is undefined for a default constructor. I want to see this complete error message. Add a constructor B. Okay, we're going to add a constructor, don't worry. So let's add the constructor now. B, that's what was bringing that error. So B, and for B we will supply it with three, because we have an additional variable that is k. So we say int a comma int b comma int c, int a comma int b comma int c. Then we need to call the constructor of the superclass, and that will give us a and b, and then we assign c to k. Okay, we are good to that level. Now we want to display k, and the method that displays k, we want it to override the show method that is actually in the superclass that is trying to show I and j. So let me just write display k and say override show in a. It's good to have comments in our programs. They help us to, it's good practice. So void show, we want to override it, so you say void show. Now to override, for us to be able to really override, we need to make sure that the name is the same, and also the types are also the same. So void show, we are supplying it with nothing. We just want it to print k. So system dot out dot print ln, we just say k, then semicolon, we can add space, then we can add k. Now can add space, then we add k. So we have overridden. So let's come to our main class, the public class override. Let's have our main method. So public static void main, and here we have string args square brackets, then we have curly braces. So in our curly braces, I want us to create a new object that is actually an instance of b. So b sub ob is equal to new b. B sub ob is equal to new b, and b at this point is taking in three variables, 1 comma 2 comma 3. Yes, then let's call the show method on b. So sub ob dot show, sorry, it should be in small. Sub ob dot show is what, hey, so sub ob, yeah, dot show, sub ob dot show. The sub ob dot show that we are putting here is actually let's say is calling show, the show method is calling the show method in b, I'm gonna show you why right a moment. Now you see, if we run this, we are calling dot show, but how many dot show methods do we have? We have two. We have this one show method here that prints k, the value of k, that is in actually it is in b. Then we have one that is in a, that is showing us the values of I and j. So let's run and see which one is going to actually be called and which one is going to be overridden. So if you check the output, shows k is 3. Which one is that? It is this one here. It is this one. the one that is actually in the subclass B is the one that is called. The one that is in the subclass, in the main, in the superclass A, is not called. It is because the one that we have in the subclass B is overriding the one in the superclass A. Now, if you wish to access the overridden version of a method, then you can use the super. Can use the super. I've demonstrated the use of super. You can use the super to access overridden overridden methods. So method overriding occurs only when the names and even the type signatures of the two methods are identical. When they are not identical, then what is simply happening is that the two methods are simply overloaded. We talked about overloading methods. They can have, if they have the same name but they have different type signatures, they are overloaded. They are not overriding each other. They are overloaded. Now, the other concept that I want us to talk about here is, I call it dynamic method dispatch. Now, dynamic method dispatch is basically a mechanism by which a call to an overridden method is resolved at runtime rather than at compile time. Now, Java implements runtime polymorphism this way. So Java actually uses the fact that a superclass reference variable can refer to a subclass object. So when an overridden method is called through a superclass reference, Java is going to determine which version of that method to execute based upon the type of object that is being referred to at the time the call is made or the call occurs. Now, this particular determination is actually made at runtime. So when we have different types of objects that are referred to by different versions of we have different types of objects that are referred to, then in that scenario we have different versions of overridden methods that will be called. That is to mean if it is actually the type of the object that is being referred to, not the type of reference variable, that determines which version of an overridden method will be executed. So if a superclass contains a method that is overridden by a subclass, then when different types of objects are referred to through a superclass reference variable, then the different versions of the methods are actually executed. That could be a lot of English. It could be a lot of English, a lot of confusing stuff. Let's just look at that by looking at an example. Let's come back here. Allow me to delete this. The reason as to why I'm deleting is because I lost track of the class names. I don't want to bother myself to think a lot about them, so I'm just gonna delete that and I will create a new class. And this new class that I'm going to create to demonstrate a dynamic method dispatch, we'll just call it dispatch. Just call it dispatch with capital D, dispatch. We better understand when we have programs. So what I'm going to do is I'm going to create a class. I'm going to create a class, the class A. And this class A, I'm going to give it a method. I'm going to call it call me, void call me, and this method is just going to print some message. System.out.println. It's going to print some message. Just say inside A's method, inside A's method. Yeah, so in other words, that statement is inside A's method. Okay, let's create a subclass of A, B as a subclass of A by extending A. So we say class B extends A. We say class B extends A. So So when we say class B extends A, here we are trying to override call me. Yes, override the method call me. We are overriding it here. So to override it, it means we need to give it same name. So void call me, give it same name and should have the same types. So void call me, and what I want it to print is the message inside this method. So system dot out dot print ln, I want it to print inside this method. Inside this method is what I want it to literally print, so that it can override the method in A. Then let's extend B to create another subclass. Let's extend B to create another subclass. We call it C. So we say class C extends B. Class C extends B. Now this one is also going to override call me method. Override call me. We're going to have a method that is also going to override. So void call me as a method, and then we have the curly braces is going to print system.out.println. What this is going to print is inside C's call me. Inside C's call me. Inside C's call me, or inside C's method. Okay, that's fine. So now in our main right now, let's create our main here. So public static void main, let's have string args, then let's have curly braces, and here we are going to create 3 objects, A, B and C. One will be an instance of the class A, another an instance of B, and another an instance of C. So to do that, we say A, then let's call the object A is equal to new A, then let's do the same for B. Let's call it B. This one is equal to new B again. Also let's do the same for C. Let's call it C. Let's say is equal to new C as well. Now we have created those 3 objects. Now what we are going to do again is I want us to obtain a reference that is of type A. So if I say AR, when I say AR, I mean now R, we are trying to get a reference of type A. So here let's put this and say obtaining a reference of type A. So I can simply come here and say R now is equal to small a. R is equal to small a. Now you see I am assigning the new object that I created, A, to R, because I have obtained a reference of the type A when I said A R. So what I'm doing here is let's say R refers to an A object. R refers to an A object. So if I come down here and say, look at this, if I come down here and say R, or rather let me just come up here and say R dot call me. I come then say R dot call me. when I say r.callMe, what I am actually calling here, as much as we have the callMe method being overridden in all the other subclasses, we are calling r.callMe, but we have given r a reference to a. So that means the callMe method that will be called there is actually the version of a. So we can say this calls as version of callMe. That calls a version of callMe. Okay, let's come down here and say r is equal to b. R is equal to b. Again, what I'm doing here, I am referring r, refers r to an object of b. Okay, then if I just say r dot call me, just want you to see what is happening. When I say r dot call me, at this point sorry, at this point, because at line 35 we are referring r is referring to b, which is an instance of the class b, or it is an object of the class b. Then it means now r is referring to an object of b. So when we are applying the call, we are calling, or we are invoking the method call me on r, then it must, or it is going to refer to, the version of that method that is of a. It's going to refer to the version of a. So we expect it to print inside a. Okay. Now let me now refer r to c. So r is equal to c. R is equal to c. I'm referring r to c now. So of course here r is referring to c. So when I say r dot call me, again here r refers to version in c. R is going to refer to version in c. Let me run this and see. Let's check the output. You see inside A's method, inside B's method, inside C's call me. So we are actually trying to, or we are doing what we call dynamic method dispatch. So A is a superclass that has two subclasses B and C. In this program, I'm explaining this program again. So we have the class A, which is a superclass that has two subclasses, that is B and C, and all these B and C are overriding the call me method that is declared in A. So in the main, we declare objects of type A, B, and C, and these are, they are here. We declare these objects of type A, B, and C, and again we give a reference of the type A that is actually called R. AR. This one is a reference that refers to A. Okay. Now the program is going to assign the reference to each type of the object to R, and it's going to use that reference to actually invoke the call me. So when we say R is equal to A, then R is going to refer to A. It is going to use this reference to actually invoke the methods of A. the call me method version of A. So the version of call me executed is determined by the type of the object that is being referred to at that time, because at this time we are referring to A, objects of A. So the version of call me, the one that will be called is for the one that is in A. Then this one refers to the object of B, so the version being called here will be the one that is in B. Again, this one, the version that will be called will be the one that is in C. Now you might be asking yourself, Why override methods? Why should we override methods? Now, method overriding allows uh, the support of what we call runtime polymorphism, which is actually very essential in object-oriented programming, since it allows what we call it allows the general class to specify methods that will be common to all its derivatives, while at the same time allowing subclasses to define the specific implementation of some or maybe all of the methods. So by combining inheritance with overriding methods, then a superclass can define the general form of the methods that will be used by all its subclasses. That is very important. So you might be really wondering, like, okay, where do we apply method overriding? So let's look at a more practical example where we apply method overriding. So I'm going to delete this again. So I will create I will right click here and create a new class. I'm just gonna create a new class, and I'll call this class find area. There's a program I want us to extend it. There's a program I want us to extend it. So we wrote a program that was using figure as a superclass, and that was storing two dimensions, the dimensions of a 2D object. It was also defining a method area that was able to compute the area of an object. We are going to actually have this. It was also defining two subclasses from figure, which was the rectangle, and the second was the triangle, that are actually that have methods that override the method in the figure, the area method in the figure, so that it is actually returning the area of the rectangle in the rectangle and the area of the triangle in the rectangle respectively. So we are just going to extend this using runtime polymorphism. We just want to extend that program. Now, for the purposes of any other person who is actually handling this at the beginning, I'm gonna start writing that program from the beginning. So I'm going to say class, let's have figure. We had figure as our superclass, and we have two dimensions, so double dim1, we have double dim2. Dim stands for dimension. Remember, your variable names should be meaningful. Then let's have our constructor. Of course, should have figure, and our constructor is taking in the two dimensions, so double a comma double b. Again, let's set up things here. Okay, just a moment. Let's set up things here by saying that dim1 is a is dim1 and b is dim2. Then let's define the method here to enable us get the area. So it's double area is our method, and what this method does is simply this method will simply print area for a figure is undefined. I'm gonna explain what is really happening here. Okay, so system.out.println let's say area for figure is undefined. Area for figure is undefined. We must return because we said the return type is double, so let's return 0. Just return 0. Yeah, we return 0. Okay, so again we need to now create a subclass of figure that is able to get the area of a rectangle. So we are going to have a class rectangle that is going to extends figure. It's going to inherit from figure. Just a moment. What is this error for? Okay. So let's give it the constructor triangle. Let's give it the constructor. Supply it with two parameters, double A and double B again, and then we have we need to invoke the constructor of the superclass. So we say super, we have A comma B, A comma B. Okay, something is wrong here. Let me check it out. Class rectangle extends figure. Let's come up here and check. Figure is okay. Let's see these errors. No. Super constructor figure is undefined for default. Constructor must define an explicit. Okay. Class rectangle extends figure triangle double A. Let me not triangle. It's in the evening. I'm really tired. We are dealing with rectangle. I don't know why I wrote triangle. Yeah, rectangle. Okay, rectangle. Then you need to have a method that is going to override the area method in the figure. So it's double the return type and the name is area, and what is going to happen is that we are printing the message system.out.print and then let's just say inside area of a triangle, inside area of a triangle, inside area of a triangle, say that inside area of a triangle. Now it must return, so it's going to return dim1 or multiplied by dim2 because it's the area of a rectangle, because it's the area of a rectangle. So again we need to have we need to have another class. We need to have another class, and this class should be extending from figure again. Let's have triangle, one that can get the area of a triangle, that is a right angled triangle. So it is extending from figure. Okay, it is extending from figure. So let's have the constructor for this class. So triangle is taking in again double A comma double B. It's taking in double A comma double B, and we need to call the constructor of the superclass of this class. Then we need to have a method. It needs to have a method that again overrides the area. So we say double area, say double area, and we actually print the message system.out.println. We say inside area for triangles, we say inside area kiasi inside area for triangle, inside area for triangle. Again, we need to have it return something. So the area for a triangle is obtained by taking the first dimension, then multiplied by the results of the division of the second dimension by 2. This is dim, not din. You need to remove that. Okay, so we can go to our main now. And come to our main now. So basically in our main, let's have our main method. So public static void main, we have string args square brackets, and we have curly braces. So in here we want to create a figure. Let's call it figure f. Let's say is equal to new figure, and this figure, let's give it the dimensions 10 10. Oh, this could be a square. 10 10. Then I want us to create a rectangle. So rectangle, we call it rectangle R, which is equal to new rectangle, and we give this rectangle the values of like 9, 12 or 5, 9, 5. Something is wrong here. Let me see. Rectangle, let's come up here. I want to see triangle, rectangle, okay, let's see what's the issue in here. Multiple markers at this line. Rectangle cannot be resolved to a type. yes, okay. All right. Okay, let's relax. I'm gonna find the issue in a bit. Let's just continue. Let's wait. Triangle. We have triangle. We have rectangle, double A, double B, super A, comma B. Okay. All right. Let's continue. I'll see. So let's create a triangle. I will know where the problem is. Create a triangle. Let's call it T. Let's say is equal to new triangle. Let's apply it 10, 8. I see similar errors. Also. Okay. So let's come up here. Let's just check our code and see where all this is. So class figure opens here and is ending where? Here, when we are getting figure so double area, so this closes this just a moment. Yes, it's just a simple mistake, huh? Yeah, okay. So we need to close that class there. Another class is opening here. Yes, then we have the constructor, we have the method, and closes here, that is okay. Another class is opening here. Constructor, you have the method, closes here, that is okay. Now this one needs to go away. Alright, yes, it's just some simple mistakes. So triangle T is equal to new triangle, we've given it 10 and 8. Now let's create let's now create a reference to figure. So let's say figure, and we just call this figref for fig reference. Yeah, figure, then figref for fig reference. So that is referencing to figure. So we can say now that figref is equal to R. Yeah, because R is an object of rectangle, which is a subclass of figure. Then let's print and say system dot out dot print ln, system dot out dot print ln. Let's print the area. Let's say area is plus, let's get figref dot area, again. Let's have figref, we call it R, we reference it to R, to T, sorry, we reference it to T, and then we print system dot out dot print ln. Here we say area is, and let's have a plus sign, again plus, we get fig ref, this time figref dot area, because we want it to refer to to the method that is actually inside triangle. So we have used triangle to create T. Okay, so let's also have figref refer to F in this scenario. We say, we print system dot out dot print ln, say area is, say area is plus that plus figref dot area again. Yes, okay. Now let's run this code. Our programs are getting longer. You will need to start pausing videos. So inside of area of a triangle, area is 45. Inside area 4, triangle area is 40. Inside area for figure is undefined. Area is that. Now let's come here. This one here was supposed to be rectangle. Let's just put this rectangle to avoid confusion. Rectangle inside of rectangle. So basically through the use of inheritance and the runtime polymorphism, we are getting the possibility or the ability to define one consistent interface that we can use to it can be used by several different but related types of objects. So if one object is derived from figure, then its area can actually be obtained by calling the area. We're just calling the area method. Okay, so the interface here is actually the same. It is regardless of the type of object that you are actually using, the interface is actually the same. So we have managed to create that interface. This is a more practical example. Guys, I'll see you in the next one when I'll be talking about using